Hello, my name is John Miller, and today I'm going to talk to you about advanced cooling. So Moore's Law is slowing down, and one of the reasons, according to the ITRS 2.0, is because as chip power is increasing, your heat flux is increasing, and because of the thermal management solutions for this increased flux, your package density is, you're not able to get as high of a package density, and this causes higher interconnected latency, higher power dissipation, lower bandwidth, and higher interconnect losses. What does this look like in a real world? So you have a server farm filled with servers. Each of those servers is filled with multi-processor trays, and those trays, the volume of those trays is defined by your thermal management solution. Heat transfer drives this whole thing. This is what heat transfer looks like in an air-cooled data center. It goes from the chip to an air sink, from the air sink to a refrigeration unit, from the refrigeration unit outside. That is a terrible waste of energy and efficiency. Those cold plates, right, those heat exchangers right there are what Moore's Law looks like in terms of heat sinks. And water's not much better. You can get some pretty good volumetric savings with it by going to cold plates, but it's plumbing intensive. You get 10 to 20 degrees C rise from the input to the output, and you have toxic corrosion and biocide inhibitors, quarterly testing, galvanic corrosion concerns, and they have accelerated mean time to failures. So what do we do about this? What we are doing is taking and skipping the single-phase heat transfer fluid and going directly to a two-phase isothermal working fluid that removes heat by get this, by evaporation. And that fluid is a refrigerant. Right now, and the reason to do this is because that fluid is very efficient. You can reduce your pumping requirements by an order of magnitude. You can increase your thermal heat transfer coefficient by an order of magnitude. And the fluid is extremely well known. In the United States alone, there's over a conservative 500 million residential and automotive applications for HVAC systems. And the infrastructure and supply chain are there. They're already there. So what does the system look like? You have four components. You have a reservoir. You have an extremely long-lasting pump. We've tested these units for over 45,000 hours. You have a cold plate, and we've developed proprietary world-class microfilm cold plates. And then you have a condenser that you can dump this heat to wherever you want, whether it be a refrigeration unit, whether it be outside, whether it be the room inside your data center. You can put it wherever you want, and maybe even feed it back into your data center for power conservation. The entire system is hermetically sealed with no maintenance required. When it's all said and done, you have a path that looks like that. The efficiency is so incredible that you don't need a compression cycle, which is the single highest energy utilization in an HVAC system. So you can eliminate that and get amazing efficiencies. And this is now. This is right now. These systems, low maintenance, you get from air, you get 2 orders of magnitude decrease in your thermal resistance. You get over water, you get a 3 to 4 times decrease in system volume and system weight. And not only that, here's the kicker, it makes good business sense. 10-year capital operating expense comparisons put it at 97% less. It costs 97% less to use a two-phase cooling solution over typical air systems. The picture right there, that is deployed custom serial cold plate array that we have sent to customers. Right now, we are working with multiple Fortune 50 companies to deploy these systems in their server systems. Two-phase cooling opens up new frontiers with increased power density, unique system architectures, and maybe, just maybe, will give Moore a few years on the curve. Thank you.